Hello guys. Today we are going to discuss about the CAP theorem, which is very important in the distributed systems regarding the DBs. Right. This video is going to be more theoretical, as in implementation it should be more in distributed systems and regarding the trade-offs and stuff. So this is going to be more theoretical. So coming to the CAP theorem, as this is also an acronym: consistency, availability, and partition tolerance. Right. So where do we use it? What does these words means? These words have a difference between the consistency which we have seen in the acid yesterday, and the consistency which we'll be seeing here today. So let us get into it, right? Right. Let us say we have a DB. Oh my god! 1 minute. I think the size is more. Okay. And size. Okay. Yeah. So let us say we have a DB. This is the master DB. So, when coming to the CAP theorem, this is mostly for the distributed systems, which means that everything will be divided. So, right, for example, you have a DB of 8 GB RAM and 20 GB storage. Let us assume the DB server is of this configuration. And let us say your website storage has been increased and your website users has been increased, and this needs extension. So there will be point where we can scale the DB, right, vertically. There are two types of scalings, guys: vertical scaling and horizontal scaling, right? So vertical scaling means increasing the RAM, ROM, which we do for the laptops and stuff, right? So that it will perform well. But horizontal scaling means replicating and increasing the total unit. So if you have 1 dB and you have upgraded it up to its fullest, like 32 GB RAM and 128 GB storage, right? And your users are still facing issues. So what you will do is take another DB with the same configurations, 32, 128. So you will be storing the data in the both things, or you will be splitting the data between two things such that the load will be divided, the traffic will be divided. The data will be same, but the traffic will be divided between the two DBs, so the latency will be faster, right? That is one thing. So, yeah, as we have now known what is vertical scaling and what is horizontal scaling, let us say here we are doing horizontal scaling, right? And we have another DB called slave, and these both are in a network for now. Sorry, guys, I'm starting to draw this, so I'm bad at it. So, these are in a network, and users are coming, right? So they will be doing pinging the master for the data, they will be pinging the slave for the data. Everything is going cool, right? So now let us say there is a network partition here, right? So these both are partitioned, and these two DBs can't communicate to them, but users can still communicate with this DB separately and with this DB separately. Got it? So this is what is meant by partition tolerance. Even though they are divided into two partitions, the users can still seamlessly communicate to each other separately, right? Alone. So user can come to the master DB, take data and go, and same as the thing. User can come to the slave DB and take the data and go. Okay, got it. Now this is about the first point, partition tolerance, right? Now again, here comes on our next thing, consistency and availability. Guys, remember one thing, this is like a vice versa thing. So when this is picked, you can only pick one of these things, right? Either CP or AP, or when you go to the SQL tables with a single node, which means there is no partition, only single node, you can pick both CA. So this is how it goes: CP or AP or CA. And Yeah, such, which means that only you can pick two of them. But yeah, in some cases we cannot pick two of these things also, right? So the maximum possibilities are you can pick two of three. We cannot pick three by three, which means that in a system you can only have consistency and partition, availability and partition, or else consistency and availability with no partitions. Why is this being only 2 by 3? Why we cannot do 3 by 3? Let me explain, right? So now let us scroll down again, draw a diagram. So as we have discussed master DB and slave DB. So again this will be given a network, and again this will be partition. Okay. Now coming to the consistency. Here, what does consistency mean is, for example, this slave DB is depending on the master DB to being backup. For example, let us say we have 10 documents appended into the master DB. So after some time, they will be again copied into the slave DB, right? So let us say user comes and he does 10 documents and read them again in the master DB. So he will write 10 documents and he will read 10 documents. There is no problem, right? And let us say there are about 10 users and they are appending about 100 docs, right? Now the users are increased, so the traffic is increased, and let us say we are diverting some users to the slave DB, and they are reading the data from here, and only 90 docs are here. So the 10 docs are not still copied into this slave DB. So which means that the data is not consistent for them. So let us say user comes, done 10 transactions and he can only see 9 transactions, and he cannot, another user come and he cannot see the another transaction. He will be worried, and that is not a good thing. So in this case, what are we gonna do is we will be just putting this as a backup, but we will not make the server available, and we'll be using the only master DB, which means that if the consistency is only the matter, so or is only the priority, then we will do this thing. We will flag the slave DB, keep it for some backup and stuff, and only make them read from the master DB such that the data will be consistent and there will be no problem in reading it. Got it? So here we can only satisfy the CP. We are only satisfying, only satisfying the CP here. So when are we going to satisfy the PA, right? So let us say again a master DB, again a slave DB, and again partition. So here we are using both master and slave, which means that if any user comes here and read docs, the data might be inconsistent. Got it? So let us say we have a very big use case like a Twitter or Instagram platform. So let us say someone like Elon Musk has posted, and the Twitter DB is now, let us say, distributed and have a small ring server like master and a slave server. We are gonna have so many slave servers, but because of this explanation I wanted to take only single thing. Got it? So yeah, when he posted something, there will be likes, there will be comments, and there will be shares, and everything has a count, right? Like count, share count, and comments, and all the comments, right? So let us say now we have prioritized the consistency by flagging this. So as it is anonymous, so many will be see the post, so many will be liking, so many will be uh, putting the comments, sharing the post, so the DB will be overloaded. So which means that any user like me comes and want to see the post, it will hang and it will block out, so we cannot see the post. So the users will be disappointed because of not seeing the post. Here, as we can see, the likes, the share, and the comments are not as important as the post, right? The post has the real content, and the likes count, the comment count, and the share count is not as important as the post, right? So, in this scenario, we'll prioritize the availability over the consistency, such that we have been dividing the data between these two things. So if about 1 million users have come, they will be going to this thing, and if it is increased and if the this DB is busy giving the data, so other users will be directed to the slave DB and can see the post. So they will not be disappointed that I couldn't see the post, this platform is not working, but they will have to see some wrong amount of likes which are not updated yet when the user is seeing post, but eventually they will be updated. So and this is called AP, right? So we are here prioritizing availability. So overall this is called CAP theorem: consistency, availability, and partition tolerance. So remember, guys, the consistency in acid and the CAP theorem is different, as I explained now, right? And the availability is here: how much is it available, and how if I put a request, I should get a response. That is what the availability means here. And this is about the DB. Got it? So yeah, and this there is an extension for this called 1 minute. I have to refer it so I can show you. So this is the notes I have prepared, such that you can also refer this and learn about the or revise the CAP theorem whenever you want it. Right now, let us go to this. Yeah, the theorem name is PACELC. I don't know how to pronounce that, but yeah. So here P means partition, A means again availability and consistency, right? We have to choose between two, or else we have to choose between latency and consistency. This is more simplified as we have discussed, which will be more accurate to the cap only. So it is just an extension of the cap. So when we do a partition, we will choose the availability or consistency, or else we will be choosing consistency or latency. As I have mentioned, latency is the speed, right? When how much latency is less, right? For example, if you're playing a game like Free Fire or PUBG, there will be latency of 99, such that if you have more ping, so you will be lagging in game, or else if you have less ping like 99 and 60, there will be no lagging game, such that it will be very less. This is the time which will take you to get the data, right? MS. And if it is 600 ms, you will get the lag. That's why that is what is meant by latency. So when you have two DBs, master, slave, you can get data from either of them. Let us say 1 million are reading from this, and let us say only half of a million are reading from this. So when you have two DBs like slave, you can go to this database and you can get the data very fast and there will be no problem. But this DB has a 1 million read limit, so you have to wait until this 1 million will read, and after that only you will get the data. So which means that you will have to wait more time, which is also latency thing, right? And here you have no need to wait and you can get the data very fast, right? So this is very not clearly, but a very close understanding of the CAP theorem extinction. Right, guys? So again, to dive deep into it, we'll be going through another thing now. So yeah, now let us see the real world applications in it. So we have banking. 1 minute, it would be better if I have visualized it. Yeah, so banking systems, which I have mentioned earlier, they have priority for the consistency, like social media with high availability, as I have mentioned, Twitter or Instagram platform. E-commerce inventory, this is also consistency because stock levels, right? If you are ordering something and it is showing as two in the stock is showing as two in the master DB, but it is showing as one in the slave DB, that is not good because you will get two orders confirmed for the single thing, right? That is not good. Yeah. So again, the content delivery, like any YouTube platform, like there should be availability, right? If you want a video, or for example, let us say some stream is being hosted, you want to see it, right? With not perfect clarity, but you want to see it, right? So yeah, like this, and we have gone through this. Now coming to the different DBs while going through this CAP theorem, right? Coming to the MongoDB, which is an NoSQL DB, which is very closely chosen for the CAP theorem because it has inbuilt sharding and it will be replicated easily compared to the other DBs like Postgres and SQL, right? So yeah, so there will be three types. 1 minute, I will also visualize this. Yeah. So yeah, there will be three types of configurations in the MongoDB, which is default configuration, which is W1, which is acknowledges after primary node, right? So the consistency is prioritized here, which is the default configuration for every MongoDB because everybody don't need the partition, right? And with majority with concern. So this is very strong CB, and with replicate ensures read and writes are complete to the majority of the replicas. So if there is a replica, it ensures that the data is consistent. It tries to ensure the data is consistent, and at last with lower write concerns. So as here we are sacrificing the consistency for the better performance, which is availability, right? So yeah, coming to the Postgres here. So as I have mentioned, the SQL DBs are mostly for the which are single load and also for the CA. As single load is there, we will follow more of the asset properties. So consistency and availability prioritize. And if you want to do partitions in the Postgres DB or relational DB itself, then we will go through this streamlined application like doing the networking splits, replicas. This will be covered when we have crossed through the phase 5 because we are not have experience of the MongoDB or the SQL writing in a direct DB for now. So yeah, and we have some tools like Citus and all to distribute the data and maintain the consistency. So yeah, and this is about the differences and stuff. You can read this document as I will be committing now to the GitHub repo. So yeah, guys, this is about the CAP theorem, right? Yes, feel free to raise PRs or if anything is wrong in the doc. Thank you, guys.